Hello viewers, welcome back to class. I'm super excited to have you guys back to class. Now listen carefully guys, if you are visiting this page for the very first time, please do consider subscribing to this YouTube channel and ensure that you turn on the post notification bell for more exciting videos. Guys, we love you. Thanks for watching our videos and our content. Listen carefully. Don't forget our policy. Do not skip any part of this video for maximum understanding and ensure that you avoid every unnecessary distractions and also ensure that if there be any part in this video you do not understand, please you can replay the video over and over again till you understand it. But if at the end of replaying the video over and over again yet you still need more clarification, please let us know at the comment section. All right, now let's get started. On the board we are asked to simplify. This is question number 4. Simplify the following. Number 1, 2 to Roman figure 6. We have the problem, so we want to provide the solution. Now, Roman figure 1, we have s raised to the power 3 into minus 5. Now, guys, understand that here in this question, you see, this thing is very simple. Yet, listen, you need to identify if you have multiple laws in one question or just a single law. Like this question we have now, we have multiple laws here. How? First, I know that there is a product law here. I have two powers. Powers to multiply power. Also, I have a negative here. So what must I do? I will come to my theorem here and see. I have product rule and I also have negative rule. Now, this question can be solved in just one line and get your answer. Minus this guy times this guy, you have minus 15. Is that correct? Yes. 3 times minus 5, you have minus 15. In one line. Just 1 second, you have your answer. Right? But in this case, we want to solve this question using any of the laws of indices. That's why we want to solve it this way. So now, I know that this 3 and minus 5 will multiply themselves later. And this minus 5 comes in based on root 4. So I can decide to first of all remove minus 5 before I now work on the product of 3 and 5. And one of the ways to easily know what to do is to know the laws in their serial number. Are we there? So this comes before this comes before this, just like that. So if I know that this law, negative power, comes before the product power, then I'll first of all implement the what? The negative power here. Are we there? So now let's quickly implement the negative power. This will have given us 1 over x raised to the power 3 or raised to the power 5. What does this mean? It means that x raised to the power 3 will multiply itself 5 times. Oh, we don't even want to go through that process. All we just need to do is that for product power, we were told that power can multiply power. So therefore, this power here can multiply the internal power. So what are we waiting for? We just simply use the internal power to multiply the external power or vice versa. And then we will have this to be what? 1 over s. 3 times multiplied by 5 is 15. 15. That's all. It's just like this. That's all. Now we have Roman figure 2, where we have 3m raised to the power 4 or raised to the power 2. This would have given us 3 raised to the power of 2 times m raised to the power of what? 4 multiplied by 2. Of course, you know that dot in mathematics means multiplication, except you have it between numbers. But when you have it between a number and an alphabet or a letter, or any other symbol, it means multiplication. Are we there? So let me just implement this here. So this power at first 3, it becomes, and understand that the power of 3 here is 1. So 2 times 1, that's how I had this. Multiplied by m has original power of 4. Multiplied by this 2, we have this. Automatically, this will have given us 9. Now m raised to the power 2 multiplied by 4, or 4 multiplied by 2 is 8. This is the answer. But another person can decide to say, no, I don't want to use this shortcut. This method is too short. Why not do it this way? This also means if I have a raised to the power 2, it's the same thing as a multiplied by a. That is to say, this bracket will multiply itself 2 consecutive times. I can have this as, this is all, for instance, alternative method, 3m raised to the power 4, multiplied by what? 3m raised to the power of 4. This is it. I want to use the first law. You see now? I want to use the first law. So in this case, I will have the number separated from the letters, then m raised to the power 4 multiplied by m raised to the power 4. So guys, 3 multiplied by 3 is 9. and m raised to the power of 4, pick one, then sum of the powers. Then this will have given us m raised to the power what? 8. 4 plus 4 is 8. So this step process is longer than this, but whichever way you solve it, you will always have your answer. You will always have your answer. Now, if it is for exam, I don't need to go. If it is objective, I don't even need this. Just pair this 9, this times this, m raised to the power 8. This step is not even needed for objective. So, whichever method you want to go with, is a matter of choice. But pen and paper. Now, we have question number 3 on the board. Okay? So, we have minus s cubed y squared all raised to power 4. We are going to be using this law here, the product law. So when we look at this now, we have product law here. And don't forget that we have a coefficient here, minus 1. You must put this minus 1 into consideration. Yes, you must take notice of that minus 1. Otherwise, you may have this question wrong. So in this case now, this is exactly the same thing as minus 1 raised to power 4 times x raised to power 3 raised to power 4 times y raised to power 2 raised to power 4. This is exactly what this means. Are we there? This 4 affects this minus 1. This 4 also affects every s raised to power 3. This 4 also affects y raised to power 2. That's all we have. It's as simple as this. We can still solve this problem the same way we have it. So it means that everything inside this bracket will multiply itself 4 consecutive times. Are we there? So this at this point now, minus 1 multiply itself in an even number ways will give you positive results. So anytime a negative value multiply itself in an even number ways, you have a positive result. So minus 1 times minus 1 is plus 1. Times minus 1 is minus 1. Times minus 1 is plus 1. You can check that out. So minus 1 multiply itself 4 times will give us positive 1. And we don't even need 1 to be here. So we ignore it. Then s raised to power 3 times 4. 3 times 4 would have given us 12. So this would have given us s raised to power 12. And y would have given us y raised to power 8. Why this is plus 1, but we don't need the plus 1. It's as simple as that. This is the answer to that question. Then Roman figure 4. We were given minus 2 p q 2 all raised to the power of 3. This one now, we are still using only product power law. So the same way we solve this question is the same way we are going to solve this. All we need to do is to have this as minus 2 raised to power 3, because this power here affects 2, then times p raised to power 3, then multiply by q raised to power 2, or multiplied by 3. It's as simple as this. Now minus 2 times minus 2 times minus 2 will give us negative 8. Are we there? Yes. So this would have given us minus 8. Now p raised to power 3 and q raised to power what? 2 times 3 is 6. This is the answer to this, guys. Then also, we have question number 5 on the board. And this question number 5 happens to be what? 36 1 over 2. And don't forget that this question looks like rule number 6, which is what? The root power law. Are we there? Yeah, that's it. The root power law or the root index law, where the numerator is 1. So what do? I find the square root of the base. So this will have given us 36 will be here and 2 will be here. But based on the fact that square root is 2 in itself, we will remove this 2 from here. So now, the square root of 36 is simply a number that we multiply itself 2 times to give us 36. And more also, we know that 36 is a perfect square, which would have given us 6 times 6. All you need to do, pick one of the values, you are done. So that means the square root of 36 is 6. Boils down from indices. Then also, this will have given us Roman figure 6. Alright, so we have 8 raised to the power minus 2 over 3. Looking at this question, guys, this question is a combination of 2 laws. Combination of 2 laws in one. As simple as it is a combination of 2 laws. How? First, I have a fraction where the numerator is greater than 1 and the denominator is greater than 2, right? which obeys rule number 7. Now I have a negative here, which obeys rule number 4. Now between rule number 4 and rule number 7, rule number 4 comes first, right? Rule number 4 comes first. So we are quickly going to first of all implement rule number 4 before we think of implementing rule number 7. Now we have this to be what? Now to implement rule number 4, we are simply going to remove this minus here, which will turn to the reciprocal of the base to the same power. Now when we have this, we are quickly going to what? Make use of this law. Either this or this. So this is going to quickly give us 1 over, you put down your square root symbol or root symbol. Now the denominator is what you have outside. Then the base is what you have inside. Then all raised to power of 2, which is the numerator, is what you have outside. What does this mean? 3 root 8 means a number that will multiply itself 3 times to give us 8. And that is 2, guys. So this would have given us 1 all over the cube root of 2 times 2 times 2. All over 2. And this would have given us 1 over 2 raised to power 2. All you need to do is to pick one of these values. That's all. Once you are able to get a number that will multiply itself 3 times to give us this number, all you need to do, pick one of the values. Alright? And now, we cannot leave our answer like this because 2 raised to power 2 means 2 multiply itself in 2 places. That would have given us 1 over 4. 2 times 2 is 4. So guys, this is the answer to this question number 4 set of questions. So guys, we are going to start looking at question number 5 as a continuation of the same video. Question number 5 on the board, we are asked to simplify the following. Now we have our solution. Number 1, we have 3 raised to power 1 over 2 multiplied by 3 raised to power 3 over 2. This is what we have here. All we just need to do is to check. We have equal base, or we have fraction as their power, right? So if I am to consider this first term here, it obeys rule 6. And if I consider the second, it obeys rule 7, where the numerator is greater than 1. But before this individual function, I have multiplication, which is rule number 1. So that means I will start with rule 1. So, and I have them to have equal base. You see now? So I will just pick one of the bases and add all their powers since they are connected with multiplication. Now this would have given us 3 raised to power. Now guys, this is fraction, and in one of our previous classes we looked at fraction extensively. And if you are new in this page, please you can check our playlist to look out for fraction, and everything we discussed in fraction are uploaded on our YouTube channel, where you can study more or learn more about what fractions. Okay, now we see that these are 2 fractions here that are being added together, and now it happens that the denominators are the same. So once the denominator of 2 fractions are the same, you can possibly add them. We can add 1 and 3. So 1 plus 3 will have given us 4 all over 2. This is when they have equal denominator, but when their denominator differs, then you can find LCM, alright? The same way, at this point, this will have now given us 3 raised to power 4 divided by 2 is 2, and finally this will have given us what? 9. This is the answer to this question. It's as simple as that. 3 times 3 is 9. 2 raised to power 3 means 3 multiplies itself 2 consecutive times. Because I explained earlier on that the number of times the base multiply itself is dependent on the power. So if the power is 2, that means the base will multiply itself 2 times. Are we there? Yeah. Now we have question number 2, problem figure 2. We have 8 over 27 all raised to the power of minus 2 over 3. Guys, this is not different from the last question or one of the questions we solved in example 4. But let's look at this. Here now, we have fractional power. Fraction as a power. This is the base. 8 over 27 is the base. This is the power. And at the power, we have combination of fraction and negative. And what do I say you do? Negative comes first before fraction using this law of indices. So negative is law 4 and the other is law 7. So we are going to start with law 4 and that would have given us 1 all over 8 over 27 all raised to the power 2 over 3. So at this point, guys, all we need to do, we know that this is fraction power law. Are we there? We are going to apply the fraction power law here. All I need to do is to find the cube root of this number and square it. Then we will have this as 1 over the cube root of 8 over 27 all raised to power 2. Now, the cube root of 8 is 2, which is 2 times 2 times 2 is 8. While the cube root of 27 is 3. 3 multiply itself 3 times, what I'm giving us 27. And cube root of any number means a number that will multiply itself 3 times to give you the required number. So we are looking for a number that will multiply itself 3 times to give us 8, which is 2, and another number that will multiply itself 3 times to give us 27. So the first one is second is 3. So this would have given us 1 all over 2 over 3. Now when we see this, we have multiple fractions here. This is a numerator, and at the denominator of this general numerator, we have another fraction. So what do? Listen to this carefully. I'm going to have this as 1 divided. This long division is what we turn to this division 2 over 3. And also in fraction, we said that there is no way you can divide two fractions directly without what? Converting the fraction to multiplication. So what we are going to do now is to change this division sign to multiplication and then invert the fraction that comes immediately after that sign that we changed. Are we there? So this will have given us 1, you can put this in the fractional one form, times 3 over 2. And the final answer of this would have given us what? 3 over 2. This is the answer of 1 whole number 1 over 2 in mixed form. This is the answer to this. Then we have question number 1, question number 3 on the board. And question number 3, we have 64 raised to the power minus 5 over 6. This question is not different from the one we just saw. They are the same. Only that here the question came in fraction. We have the base to be in fraction, but here now we have the base to just be a simple term, right? All we need to do now is to also first implement law number 4 by removing this negative and turning to the reciprocal of the base to the same power. Then we have 1 all over 64 raised to the power of 5 over 6. We just removed the negative. Now the next thing we are quickly going to do here, guys, is to find the sixth root of this denominator, because this is law 7. So the denominator is b, which will be outside. Therefore, we will have this to be what? 1 all over the sixth root of the base 64. Don't forget the base is what is inside, then all raised to the power of 5. Now, the sixth root of 64 is a number that will multiply itself 6 consecutive times to give us 64. One number that will multiply itself 6 consecutive times to give us 64. And that number happens to be 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That's 5. Now 32 times 2 is 64. So that means the sixth root of 64 is 2. So this becomes 2 raised to the power 5. And guys, 2 raised to the power 5 is exactly the same thing as 2 multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. And our final answer becomes 1 all over 32. This is all about it. It's as simple as this. Now let's go. The next thing we have on the board is question number 4. Now we have question number 4. And question number 4 is not still different from question number 2 and 3. Question number 4 and this guy, they are the same. Now, here we have 18 over 32 all raised to the power minus 3 over 2. A combination of log 4 and log 7. Numerator greater than 1 fraction. So first I will implement law 4, which will happen that make this expression to be what? 1 all over 18 over 32. You see now, that division must be the longest division. 3 over 2. Now, the next thing we are quickly going to do is to check whether these numbers inside the bracket have something in common. Because 18 and 32 have something in common. That can reduce them. Are we there? They have something in common. So, what is the common factor between 18 and 32? 2. So, we are quickly going to divide 18 by 2 to get 9, and also divide 32 by 2 to get 16. Why am I doing this? I already know aforetime that the square root of 18 is impossible. It must come with decimal point. And we don't need decimal point. Similarly with what? 32. So I need numbers that will give me perfect result, values without decimal point. So that's one of the reasons why I just quickly check whether I can find a number that can reduce these numbers here to their respective perfect squares. Are you there? It's not common. Now, all I need to do now, this is now giving us 1 all over. Now we introduce square root. This is where the 2 will start. Then this is where we'll have the 18. But when we divide 18 by 2, we have 9. And when we divide 32 by 2, we have 16. All raised to the power of 3. Alright, but being that square root is already root of 2, then I will remove that 2 there. If you put 2 here, you are very, very wrong. You don't need to put that 2 there, okay? Don't put 2 here. Then the next thing we do is, at this point, we will be looking out for a number that will multiply itself 2 times. Don't forget that's what square root is all about. A number that will multiply itself 2 times to give us 9, and another number that will multiply itself 2 times to give us 16, and that happens to be 3 and 4. Alright? So this will have given us 1 all over 3 over 4, all raised to the power of 3. And guys, don't forget that this is equivalent to 1 all over 3 times 3 times 3 over 4 times 4 times 4. This is at the denominator. So guys, when we simplify this further, 3 times 3 is 9, and 9 times 3 is 27. So we have 1 all over 27 over 4 times 4 is 16, and 16 times 4 is 64. Then we have 64. And now we cannot leave our answer having this multiple fraction. We have a numerator and denominator, and the denominator is in fraction. So we cannot leave it like this. What do? We also need to split this. This is equivalent to what? 1 divided by, take this one, take this long division, 27 over 64. Alright? Yeah, 27 over 64. So, we put down 27 over 64. Now, understand that we cannot leave our answer with this, so we can simplify this with this division sign without converting division to multiplication, still using the law of fraction. So this will have given us 1 over 1 multiplied by 64 over 27. Now, 64 times 1 is 64, and 1 multiplied by 27 is 27. This is our answer, or we can leave this in what? In mixed fraction. So we need to know how many times 27 can go into 64. So 27 will go into 64 2 consecutive times. Are we there? Which would have given us 54. So you put down 2. Then your division, put down 27. Put down the denominator because the denominator remains unchanged. So we want to get the numerator that is left there. 2 times 27 is 54. Now remove this 54 from the original numerator to get the new numerator. So 64 minus 54, that would have given us 10. That's all about this. So this is the answer to this very question. Now we have question number 5, which we are asked to solve for a cube b multiplied by open bracket 3ab all raised to the power of minus 2. All of these things are very simple, easy to do. First, listen that. First thing you do here is to check this multiplied by this has introduced law 1. This last term is connected with rule number 4 or law number 4. right? Now, it's a matter of choice, but like I do always advise, you can make use of rule number one first. Make use of rule number one first. Listen carefully. This question that we have here now, we can solve it in numbers of ways. You can solve it in like 3-4 methods to solve this question to get answer. But because we are dealing with indices, we want to use any of the laws of indices possible to solve this. Alright? There are many ways to solve this problem we just have here now. Now let's use any of the laws of it. So how do we use law 1? For us to be able to use law 1, that means I need to accept each of these by the power. I need to use what? The power law first. So I will multiply this negative 2 with all of this. I have that done. Or you can decide to what? Implement rule number 4. Anyone you want to use, but ensure that one of the laws is implemented. Are you there? Alright, so these are giving us 4 a cube b multiplied by 1 all over 3 ab. So I choose to go with law number 4 first. So at this point, this is exactly the same thing as 4a cube b over 1 in fraction form multiplied by 1 all over. Now this will have given us 3 raised to power 2 multiplied by a raised to power 2 multiplied by b raised to power 2. Okay, this is what we have. Now at this point, this will have given us everything at the numerator multiplied by 1 will have given us 4 a cube b all over 9. 3 raised to power 2 is 3 times 3, which will give us 9 times a raised to power 2 and b raised to power 2. Now we are done with this. The next thing is, this is a raised to power 3 at the numerator, a raised to power 3 at the denominator, this and this. All we need to do here is to implement rule number 2. So now when we bypass rule number 1 and use rule number 4 and 5, it leads us back to rule number 2. At this point, like I said, you can decide to cancel out here. But I want us to use any of the laws of indices. Are you there? Yes. So now, this is by giving us 4 over 9 multiplied by a raised to power 3 minus 2 for a. The power at the numerator minus the power at the denominator for division sign. Then multiplied by b raised to power 1. The power here is 1, right? Then minus the power at the denominator. Now this will have given us 4 over 9 a raised to power 1. Now 3 minus 2 will give us 1. So 3 minus 2 is 1. And now 1 minus 2 is minus 1. So finally the answer to this question would have given us 4a over 9b. Understand that b raised to power minus 1 is the same thing as 1 over b raised to power 1, which is 1 over b. That's exactly. So this b raised to power minus 1 will come and meet the term at the denominator. So this is the answer to this very question. Guys, thanks for watching. Don't forget to subscribe to this YouTube channel if you have not done so, and ensure you turn on the post notification bell for more exciting videos. So share this video and ensure that you like this current video you just watched. In this session of our class, we are asked to simplify 3 questions here. Alright? So if this is our solution, so the first question we are quickly going to look at here is Roman figure 1. And this is 4th root of 16a raised to power minus 12. And don't forget that this a is the one affected by minus 12, not 16. So the power of a is minus 12, and we are quickly going to remove that negative power from there and quickly turn it to the reciprocal of the base, to the original power, positive power, right? So this is equivalent to 16 a raised to power 12. You believe that a raised to power minus 12 is same as 1 over a raised to power 12. That means this one will be multiplied by the 16, which is the numerator. So this is what we have. Now at this point, we are quickly going to find Numbers that when we multiply them 4 times, this is what fourth root is all about. A particular number that when you multiply it 4 times, it will give you 16, and a particular number also in terms of a that when you multiply it 4 times, it will definitely give you a raised to the power 12. For a raised to the power 12, all you just need to do is to divide 12 by 4. It's as simple as that. Don't forget, for alphabets or variables, letters, once you have a power, just divide the power you have here by the nth root. So we are going to be dividing 12 by 4. So if 12 is divisible by 4, that means it will work that way. Alright? So all we just need to do now is that this will have given us the square root of 2 multiplied by 2 multiplied by 2 multiplied by 2 will give us 16. While when you divide 12 by 4, you are going to have 3. That means this is a raised to the power 3 multiplied by a raised to the power 3 multiplied by a raised to the power 3 multiplied by a raised to the power 3. This is exactly what will give us 12. So when you pick one of the base and add up the 4 powers, you are definitely going to have 12, right? Now that we have been able to get the number that will multiply itself 4 times to give us 16 and a particular variable to base a that will multiply itself number of times to also give us a raised to the power 2. Then all we need to do, we pick one from the numerator, pick one from the denominator, and that's the answer. So from here we have 2 over a cubed. Okay. Now we head on to question number 2. Now in question number 2, we have, okay, let's take it to this page. We have 1, 2. 75 a squared b minus 2 all over 5 a cubed b minus 3. And this is equivalent to, all we need to do here is to split the numbers from the letters. Automatically we can say that this is 75 over 5 multiplied by a raised to the power 2 over a raised to the power 3 multiplied by b raised to the power minus 2 all over b raised to the power minus 3. It's as simple as this. So all we need to do now is a divided by a follows rule number 2 and b divided by b also follows rule number 2 either, right? So we have this here. Now 75 divided by 5, that will have given us 15. Then we put down 15. We put down 15. Then multiply by a raised to the power 2 minus 3 using the second law of indices. Pick the power at the numerator minus the power at the denominator. Then for b, multiply by b raised to the power. The power at the numerator is minus 2 plus minus the power at the denominator because this is division. So minus 3. So we put this in bracket. This is it. Don't forget. That is the application of rule number 2. Then here we have this to be what? 15 multiplied by a raised to the power 2 minus 3. We have this to be what? Minus 1. Then multiplied by b raised to the power minus 2 plus 3. Because minus times minus is plus. And automatically we are going to have this as 15 multiplied by a raised to the power minus 1 multiplied by b raised to the power 1. Minus 2 plus 3 is plus 1. So we put down 1 here. So finally, we know that a raised to the power 1 cannot be what? We know that a raised to the power 1 is the same thing as what? 1 over a. So what we need to multiply by 1 over a multiplied by b. So in each fraction form, we have this all true. Now when we multiply out the numerators, we are going to have 15 multiplied by 1 multiplied by b, we have 15b. And 1 multiplied by a multiplied by 1, we have a. This is the answer to question number 2. Then number 3. Question 3, we have 5s cubed divided by 25 x raised to the power 6 all raised to the power of what? 1 over 2. This is question number 3. So what do we do to this question? First, we have division here. So we can decide to convert this question we have now to this format. If I believe that a over b is the same thing as a divided by b, then I can use this method. I just convert it to this format. So let's convert so that the solving will be easier for us. So this will be 5 raised to the power 5x raised to the power 3 all over 25. This division is what we just converted to this other form. Raised to the power 2. Raised to the power 1 over 2. So this is equivalent to 5x raised to the power 3 all over the square root. Don't forget that this is rule number 6, where you have fraction, but the numerator is 1 and the denominator is 2. So we have the root of 25 x raised to the power 6. Now at this point, guys, what else do we do? All we simply need to do here is to what? Find the square root of 25 and the square root of x raised to the power 6. Now I explained earlier, the easiest way to find the square root of a variable raised to any power is to divide the power by the nth root, and understand that the root here is root 2, right? So we are going to divide 6 by 2. That would have given us 3. That is to say, here we would have had this as 5x3 all over square root of 5x3 times 5x3. This is what gave us this. 5 times 5 is 25, and s raised to the power 3 times s raised to the power 3. Pick one of the base, add up the power, you will have 6. This is it. Now that we have successfully gotten this, it then shows that we are going to pick one of the values inside the square root. So if we can split this into 2, then we pick one of it. Automatically, this will have given us 5x raised to the power 3 all over 5x raised to the power 3. So 5x raised to the power 3 is 1. I don't want us to use another law again, because we can still make use of s raised to the power minus 3. We don't want to use another law. So 5 divided 5 is 1. X cubed divided x cubed is 1. So the answer to this question is 1. Guys, hope this is exciting and mind-blowing. Alright, so we see how we can solve more problems in another subsequent video. So thanks for watching this video. Love you guys. Don't forget to subscribe if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. We love you guys. Thanks for watching. Please don't forget the comment section to make your necessary comment there, and ensure you share this video. We are asked to simplify 16 raised to the power 3 over 4 multiplied by 4 raised to the power 1 over 2 multiplied all over 8 raised to the power 5 over 3. Guys, this is very, very simple. All we need to do, hold down our solution and identify the laws that are applicable here. There are so many ways you can solve these problems. So many. I will show you how we can solve it. So many ways. Now let's get started. We have this as 16 3 over 4 multiplied by 4 1 over 2 all over 8 5 over 3. This is equivalent to. Now I can decide to solve the numerator using rule number 1. I can also decide to solve the numerator using rule number 7, just to solve them individually. So we are going to solve this individually. Now, how do we solve them individually? For 16 raised to the power 3 over 4, this obeys the 7th law of indices, fractional power. This will have given us the 4th root of 16, all raised to the power of 3, multiplied by the square root of 4, all raised to the power of 1. Then all over, at the denominator, this also happens to be what? Rule number 7. So all we need to do now is also to create our root, then put down 8. Outside this root becomes the denominator, and the numerator becomes the power. As simple as this. The next thing we are going to do to have this solved is, what is the 4th root of 16? Now then, the 4th root of 16 is a number that will multiply itself 4 times to give us 16, and that number is 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 4 times. So that would have given us 2 raised to the power of 3. Then multiply by 4. The square root of 4 is a number that will multiply itself 2 times to give us 4, and that is also 2. All over, at the denominator, we have a number that will multiply itself 3 times to give us 8. That's the cube root of 8, and that will also give us 2 raised to the power of 5. And guys, this will have given us 2 raised to the power 3 multiplied by 2 raised to the power 1 all over 2 raised to the power 5. Now, applying the laws of indices, we know that this will give us 2 raised to the power 3. Now, the relationship between the numerator is multiplication. So, we add the powers while we pick one base. Then, at the denominator, we also have equal base. And now, to division, we have minus 5. As simple as this. I don't want to use any of the laws of indices. You can decide to multiply out, then cancel out at the end. We still have the same results. But I want to use one of the laws of indices. I want to use both the first law and second law. Understand that this question can also be reinterpreted as 2 raised to the power 3 multiplied by 2 raised to the power 1, then divided by what? 2 raised to the power 5. And this would have given us 2 raised to the power 3 plus 1 minus 5 using the first law and second law of indices. Multiplication is addition and division is subtraction. Then this would have given us 2 raised to the power 3 plus 1 is 4, and 4 minus 5 is minus 1. And using the fourth law of indices, this becomes 1 over 2 raised to the power 1. And this is the answer to this very question when we solve this question using this particular method. You see how exciting this is. This is question number 8 on the board. We are quickly going to simplify this. Let's go. Now, on the board, we are asked to simplify. We are asked to simplify square root of 50p cubed, p raised to the power 3, q raised to the power minus 2, all over p raised to the power 5, q raised to the power 8. Now we have this solution. We have 50p cubed, q raised to the power minus 2, all over 2p5, q minus 6. And all of these are inside square root. So the first thing you do is to create your square root, then separate the numbers from the letters according to their what? Likeness. So 2 over 50 over 2, then multiply by 50 p times p3 all over what? p5. Then multiply by q times q minus 2 over q minus 6. Alright, so this is what we have. Then the next thing we do is to what? Apply the law of indices. Any of the laws of indices. Of course, 50 divided by 2 will give us 25. You can put 25 over 1 if you want to. Then p divided by q is the same thing as p cubed divided by p raised to the power 6. And when we have this, all we simply do is to pick one of the base, pick the first power minus the second power, which is 5. Are we there? Then multiply by the same thing that happens to p, we happen to q. So pull down q. At the numerator we have minus 2. At the denominator we have minus 6. All in square roots. Alright, so this is what we have. Now at this point, all we just need to do is to have this as 25 multiplied by, when we remove 5 from 3, we have this to be p raised to the power minus 2 multiplied by q raised to the power minus 2. Minus times minus will have given us plus 6. Then we have this to be what? 25 multiplied by p raised to the power minus 2 multiplied by q raised to the power what? 4. Don't forget minus 2 plus 6 is plus 4. Are we there? Yes. Now, at this point, we have the square root of 25 times. Don't forget that we cannot give our answer as a negative power. So we need to remove this negative with the use of what? Rule number what? 4. Therefore, we have 1 all over p raised to the power 2 multiplied by q raised to the power 4. When we multiply out this will have given us the square root of 25 q raised to the power 4 all over p raised to the power 2. Now what will be the final answer here? Find the square root of these terms individually. What is the square root of 25? 5. 5 times 5 is 25. What is the square root of q raised to the power 4? Like I explained earlier, if I know that here is 2, I will just divide the power of q by 2. So if I divide 4 by 2, I will have 2. That means this will give us q raised to the power 2. Then all over, the power of p is 2. So when I divide 2 by 2, I have 1. So this becomes p. This is the answer to this very question. So guys, it is easy. Therefore, this is equal to this. Now let's look at another question again. Thank you for watching. Don't forget to subscribe to this YouTube channel. If you have not done so, make sure that you turn on the post notification bell for the video. We love you. Thanks for being our fan. Thanks for following us. Help us to share this video if you find this content helpful. Alright, see you guys in the next video.